Alright, in this video we're going to look at one last example of using Euler's method that comes from a question from the 2010 AP exam. We start with a differential equation, dy dx equals 1 minus y. And our first portion of this is going to be to use Euler's method starting at x equals 1 with two steps of equal size to approximate f of 0. So I'm going to go ahead and set up my Euler table. We've got x sub n and y sub n and dy dx, and then I need y. Alright, and we're starting at 1. We're using two steps of equal size, and we want to get to the value of x at x equals 0. So our dx is actually going to be a negative 0.5 in this one. This is the first time we've worked with a negative dx. But since we're moving from 1 to 0, we've got dx equals negative 0.5. Okay, so let's see. We're told that initially when x is 1, y is 0. So I'm going to go ahead and fill that in. And then in order to find my dy dx, I'm given the initial differential equation that dy dx is equal to 1 minus y. And so when y is 0, dy dx is going to be 1. And so my new y is going to be 0 plus dy dx times dx. And so that's going to be negative 0.5. And now I'm going to go ahead and calculate my new dy dx. It's 1 minus negative 0.5, so that's going to be 1.5. And so my new y is going to be negative 0.5 plus 1.5 times dx, which is, again, negative 0.5. And if I calculate this out, that's going to be negative 0.5 minus 0.75, so negative 1.25. So my approximation for f of 0 is going to be negative 1.25. Okay, now let's do these last two examples. Again, just to kind of review some concepts that we've seen before. In part B, we're going to find the limit as x approaches 1 of f of x over x cubed minus 1. And so if we evaluate this limit, f of 1, given to us in the problem stem, f of 1 is equal to 0. So as x approaches 1, this is going to be 0 over 1 cubed minus 1, or 0 over 0. And so in order to find this limit, we want to apply L'Hopital's rule here. So this is equal to the limit as x goes to 1 of f prime of x over 3x squared. Now, that's going to be f prime of 1 over 3 times 1 squared. F prime of 1 is the value of dy dx when x is 1, and when x is 1, y is 0, and so dy dx is going to be equal to 1 minus 0 over 3, or 1/3. Alright, and the last one, we're supposed to find the particular solution to the differential equation, dy dx equals 1 minus y. The fact that this variable that's on the right-hand side is in the numerator of my differential equation tells me that I'm going to need to use separation to integrate this. And so I'm going to go ahead and do that. Come on, scroll. There we go. And so we've got dy dx equals 1 minus y. And when we separate, that turns into y over 1 minus y equals dx. I'm going to integrate both sides. The integral of this is the opposite of the natural log of 1 minus y. And the integral of the right-hand side is x plus c. Now I want to solve this for y and use the initial condition. So I'm going to multiply both sides by negative 1. Raise both sides e to that power, which is going to give me 1 minus y equals c e to the negative x. Subtract 1 from both sides. And multiply both sides by negative 1. And now I'm going to utilize the initial condition to solve for c. The initial condition was that when x is 1, y is 0. So 0 equals c e to the negative first plus 1. So 0 is equal to c over e plus 1. If I subtract 1 from both sides, multiply both sides by e, I get that c is equal to negative e. So this turns into y equals negative e times e to the negative x plus 1. And I can multiply those e's together and add their exponents. And I end up with this being the particular solution to that differential equation with the given initial condition. Alright, so that was Euler's method and a little bit of review, some review of L'Hopital's rule in context, some review of separation, integration by separation. And that's the end of this lesson and the end of this unit. See you guys next time.